Supplemental math videos from Circle Christian School. Welcome to proofing. The first proof that we do is going to be in algebra, and the most common proof that we do is called a two-column proof. It's all about the argument, coming up with a statement and then some sort of reason, whether it's algebra, a definition, a postulate, or a theorem, that you were allowed to go make your statement. By the way, an extra 10 points for telling me what properties are on the board behind me. All right, we are given that 3 times x plus 4 equals negative 2 times 4x minus 9. Let's prove that x equals 6 over 11. This is an algebraic proof. We're going to make statements and then we're going to give reasons to them. So I'm going to start with the very first statement, and the first statement is always the easiest statement because it's always something that you've been given. So we're just going to write the original equation here. And anytime that you write any of the givens there, then of course the reason why is that it had been given. There should always be at least 2 parts of every proof that you should have, and it should be the given part and then the ending part, what you had to go prove. The stuff in between can be a little bit here and there, but that's okay. My point is to try to do the best you can, give it some sort of statement, some sort of reason, and then if you're not sure, go back and check the answer and then refine it from there. That's okay. Now I'm going to make my second statement, and when you make a statement, it's a resultant of what you had done. You don't show the work in this, you just show what the result of the work was. So we have 3x plus 12 equals the negative 8x plus the 18. And then we're going to give the reason why we were able to do that. And all great geometry students said the distributive property. And with me, it's okay to abbreviate things as long as I can really tell what you're talking about. So give me enough information in your abbreviation to qualify what you're trying to say. So now we're going to go on to step 3 here. And step 3 means we're going to have to isolate some variables and things. And so our first thing on the next one is that we need to isolate the variables. That's kind of how I do this next step. So I'm going to have a 3x here. The 12 obviously moved off. The negative 8x over here. And 18 take away the 12 is going to leave me with a 18 take away 12, a positive 6. Very good. And we got to say the reason why that we were able to do that. I mean, if you have to, go ahead and show the work here. Show that you took away a 12 and you took away a 12. I will not get upset that you did that. There's no problem with that. It's just like solving any algebraic problem. You can show the little reasons why. I mean, you can show the work. It's okay. But I'm just generally going to tell you that when you see a proof in the book, it's not going to have that. It's going to assume that you know that you had done that, and you're going to give the great reason why. And the great reason why here is, in this case, we were able to subtract. So it was the subtraction property. Maybe I'll put a T there so it doesn't get mixed up with substitution. So subtraction property. Okay, now I actually call this star step 2 because that's the steps in the kingdom when you're isolating by using the additive inverse type of thing. So you may also use that if you like, or I will know that it's kind of that either way. So now we're going to go to the next one, which is going to be step 4. which is going to leave us with an 11x equals the 6. And again, you can go ahead and just kind of show a little bit of the work here, if you like, and the in-betweens. I'm going to tell you that when you do proofs, leave lots of room in between stuff, because sometimes stuff happens in between and you have to kind of go back. So I'm just showing that this is what happened here. And I'm going to do step 4, and the reason was, again, at this point it's an addition property, but to tell you the truth, what we did was the additive inverse, so we were still doing star step number 2. Doop, doop, doop. Write it out there. Very good. And so now we're going to go to what has happened from here, and we end up with x equals 6 over 11. And the reason why, and again, if you want to leave a little space and kind of show out your work because that helps you, that is perfectly okay with me. The book won't show it, but if you want to show it to me, no problem. I love stuff like that. And the reason why here is we use the division property. But in my case, what we did was star step number 3, the multiplicative inverse property. And now we've gotten to where we have proven, okay? Again, I said you should always have at least 2 parts inside your proof that are always going to be true and always going to be right. And the first one's going to be something given, and where you end up with is something proved. Statement, reason, reasonable argument. Okay, now go make reasonable argument as to why mom should make you cupcakes. Okay? Have an awesome day.